doing it, right? So keep that in mind. When we have a system of equations, you could use any of these three methods to solve. The other day, Andrew said this one seems like the easiest. And I would say that, like, when this one works, absolutely, right? Because you just add some stuff together and then automatically you're in an equation with one variable, super easy to solve. But I think each of them have their own times when they could be easiest or not, right? And so the ones we're looking at today are, notice how we don't have any coefficients that match or are opposite. And we still want to solve by elimination. And so the question is, what are we going to do with this? And essentially, we just either need to make them match or make them be opposite. And the easy one I see is, remember, if you multiply one side of an equation, as long as you multiply by the other side of the equation, everything stays the same. So what I'm going to do is I'm going to multiply this entire equation by 2, right? And what that'll get me is I'll get 2 times x, which is 2x, 2 times y, which is 2y, and then equals, and then make sure you do this 2 to this negative 9 as well. It's everything. 2 times negative 9 would be negative 18. And then this one I'm just going to rewrite as it is. And then you'll see the whole reason I did that was because now I have 2y and negative 2y, so I can just add straight down. 2x plus 5x is 7x. Plus 2y minus 2y cancels out. Equals 32 minus 18. 1 second. Is 14. And then we have that equation of one variable. We just divide and solve. And then always remember, this isn't our answer. We also need our y values. So I'm going to go back up to the top and plug it in to one of the two equations. I'm going to choose the top one because I think it's easier. So if I go up here and I plug it into this top one, then I'm going to get x, which we just said here was 7, plus y equals negative 9. Subtract the 7 to solve for y. 7 minus 7 is 0. Y equals negative 16. So our answer would be the point, x value first, then y value. Right? And again, the reason this stuff works is as long as you multiply one side of the equation by something, we multiply the x and the y by 2, and we multiply the negative 9 by 2. As long as you do it to the other side, it stays the same, right? And then again, the reason we can kind of add these is, remember, if you add something to both sides of the equation, it stays the same. And so we added to this left side, we added 5x minus 2y. And to this side, we added 32, which you might be like, oh, well, how is that adding the same thing? Well, isn't there an equal sign here that says 5x minus 2y is the same thing as 32? So we've really just added the same thing to both sides, which is part of the reason why this works. And so sometimes adding or subtracting equations will not eliminate another variable, but you can use multiplication or at least common multiples to find a common coefficient. So you want to get one of the coefficients to match or be opposite. And here's a list of steps, but again, I hate writing down steps, so I'm going to skip off this slide pretty fast. So if you are taking notes at home, I'm scrolling through these steps so that on the video that I will post on Google Classroom later, if you want to write down the steps, you absolutely can. But I think the idea is much more important, right? And so essentially, if you're still doing elimination, right, the whole goal of elimination is to have coefficients that match or are opposite. And so if they don't match or they're not opposite, then make them match or be opposite, right? So in this example, solve system of equations algebraically, and we want to do it, or that's the one we just did. So we can do the second example, right? And now, again, neither of these match, and it's hard to get 2 to match with 5, but I can get y to match with 3y if I multiply by 3, right? Now, I'm also going to give you guys a bonus tip here. Remember how we could add or subtract either of these? So I can multiply the top side by 3, but then I would have to subtract, right? Because I would want 3y minus 3y. I personally like adding more, so I'm going to do a little trick up top, and I'm going to multiply by -3. I'll do it in black first. So I'm going to multiply everything by -3. Just be careful with the negatives. -3 times 2x is going to be -6x. -3 times y is going to be minus 3y. -3 times 0 is still just 0. And we can rewrite this one as 5x plus 3y equals 2. And so my whole point in doing that was I just think it's easier to add. If multiplying by negative seems more complicated to you than multiplying by positive and subtracting, then by all means do that. -6x plus 5x is going to be -1x or -x. Minus 3y plus 3y cancels. 0 plus 2 is just 2. And then to solve, we just divide by -1. We get x equals -2. All right, that's only part of it. We need to plug it back into one of the top 2 equations. I'm going to pick the top one. It looks easier. So then we get 2 times x, which we just said was -2, plus y, which we don't know, equals 0. 2 times -2 is -4. To get rid of a -4, we just add 4. And then our solution, again, is a point to the ordered pair, x value first, and y value. Again, if you wanted, you could have just multiplied by 3, but then you'd have to subtract and keep and make sure you subtract everything. I think it's easier to just make an addition. And so that also goes for, even if you had variables that matched, maybe 3y and 3, let's say we started out like this, right? Or maybe we started out with plus 3y and plus 3y. You could multiply one equation all by -1, so then you can add, right? It's essentially the same thing, but that is totally up to all of you.